Alrighty, so here we have the 6-3 assignment, and we're going to get started. You are going to want a graphing calculator, so if you get that one online, or you can go ahead and, grab a physical graphing calculator. That's cool. So, first thing that we're going to do is put our calculator in parametric mode. So, hit your mode key and make sure that instead of function, you are now in parametric mode. Alright. Beep, beep, beep. Okay. So once you're in parametric mode, then what they want you to do is match the equations with their graph and identify the viewing window that seems to be used in here. So basically they're saying, is each of these tick marks used as 1, or does it go by 2s or 10s or something? So I'm going to go to y equals first, and I'm going to type in 4 cosine to the power of 3, which in my calculator, you actually, well, in most calculators, you're going to have to write 4 times cosine of t, but cosine of t in parentheses to the power of 3, because they don't do the, what's called the little exponent before, or right after the cosine in your calculator. So, to the power of 3. Alright. And you are going to want to be in radian mode. So again, going to your mode, you want to be in radian. Otherwise, you're not going to be able to visually see what's happening. So, alright, so if we're in a standard window, let's see what happens. I didn't graph the y equation. Okay, so the y was going to equal 2 times sine of t to the power of 3. Alright, so as I look at this one, it is in fact giving me a diamond shape. If I move my, if I zoom in a little bit, because mine's on 10 by 10 right now, it definitely would look like these would each be going by 5. So if you want to, you can go into the window and you can change your x min to -5, your x max to 5, your y minimum to -5, and your y maximum to 5, and you get the exact picture here. So we're going to say that 1 is b, and that the window is going to be negative. Let's see, the x's are -5 to 5, and then the y's are -5 to 5 as well. Alright. They probably use point notation in the answer key, but there we are. Alright, so then we go to number 2. We go back to y equals and clear out what we had. And now we're going to type in just 3 cosine t. And, oops, 3 cosine t, I typed it in the wrong one. And then sine 2t, double angle. Alright, and I ended up keeping it at -5 to 5, and it graphed it completely. Now, some of you may be having a weird t-step. My t-min is 0, and my max is 2 pi, and then my t-step is 0.13, so that must be some fraction of pi, maybe like pi over 6 or something. Nope, definitely pi over 12, maybe? Whoops. Typed that in the wrong one. It's not even. I think it's actually pi over. Let's see. Apparently it's pi over 24. Whatever. So if you weren't getting that shape, it's because your t-step, if you go to the window on your calculator, was not small enough. So apparently this one was pi over 24 to make it nice and smooth looking. You could have just put in like 0.1 or something. It would work too. Alright. So that means that this is the image of D, if you do that nicely. And our x's ended up being from -5 as well to 5 again. And then the y's ended up being -5 to 5. It just helps you understand kind of where that point would be in reference. Alright, so the next ones we're going to do is either going to be this guy or this guy, so a little spiral there, or a cardioid. So, going into your y equals again, we're going to do x equals, so 2 cosine of t plus 2 cosine of t squared. Alright, and then the other one is 2 sine t, and then plus sine of 2t. Alright, so I ended up keeping the -5 to 5 grid, and it turns out that's what this is as well. So we're just going to end up with part A as number 3 here, and we're going to just say same window as number 1 or 2, in fact. Alright, and then the last one, go back to y equals, type in sine of t minus t cosine t, and then y is going to equal cosine of t plus t sine t. So again, just typing that into the y equals, hitting the graph button, keeping it as a window of -5 to 5. Which actually didn't do it. So let's see if that's 2 1/2. I think it must be by 2's, but it's a 10 by 10 window. So let's see, I'm going to go into my zoom key, and actually the easiest way to do it is go down to number 6, which is Z standard. Let's see if I get the whole grid. Alright, so what happens is if you do a standard window, you end up only with like this amount, and that's because you don't have a long enough section of T. And so they're just saying that 1 revolution, if you plug it in, will only get you like part of that spiral. And so we're going to have to go to our window and extend it from 2 pi to like 6 pi. And go back to the graph. So again, your T, I think it was max, ended up being 6 pi. Whoa, that ends up doing a lot of it. And it actually needs to be a bigger window than 10 by 10 because it doesn't quite show the bottom of this. So that's going to have to be a window with a y value that is lower than -10, so maybe -15. So we go back to graphing after editing the window. And now that I went down to -15, it's a little, let's see, 15, 14, 13, 12. Probably should have just done a window from -12 to 12 for the y minimum and the maximum. Alright, so that means that the last one is C by process of elimination, but my x values are actually from, let's see, is that a 10? Yeah, -10 to 10, and then the y values are going to be -12 to 12-ish. It's not perfect, but... And again, to get that, you needed to change in your window key, that blue button at the top, you needed your T max to be 6 pi, otherwise you're not going to see the whole spiral. Alright, so then we move on. So in exercise 5 and 6, is 6 on the next page, nope, it's down there. We need to complete the table, so this guy here, and plot the corresponding points. Ooh, interesting, okay. So, in order to do that, all we need to do is, we could use a table in our calculator, but basically we're just saying in order to fill in this row, you use this equation. So I need to take every t and add 2 to it in order to get my variable here. So 0, add 2 to 1, and we get 1, 2, 3, and 4. Alright, and then to get the next one, we're going to do 1 plus 3 over t. And so this first one ends up being 1 plus 3 over negative 2. So it's negative a half. Alright, then we do it with negative 1 in the denominator, so you get negative 2. If you put 0 in the denominator, you're going to get undefined, so there's probably like a asymptote there or something. And then we're going to have putting in the number 1, so 3 over 1, so that's 4. And then 3 over 2, so 1 plus 3 over 2 is 2.5. Alright, so if we fill this in at time negative 2, which doesn't make sense necessarily, but that's what we're looking at, we have over 0 down negative a half, so that's here. And then to make sure that everyone knows what's happening, you usually write t equals negative 2, and it associates with that point. Then the next one is at 1, negative 2, so I will go back to that later, but let's see. The next one is 1, negative 2. Oops. So I'll put a black dot for that one. At 0, we've got 2 undefined, so should probably draw an asymptote there. At 1, we have 3, 4, so over 3, up 4. And then the last one, over 4, up 2.5. So from what I can tell, we're probably going to get to this kind of a thing here. Some ellipses type equations. And of course you can graph more points to kind of get that, but we do note that there is an asymptote at 0, at time 0, so I'm going to go back through and write in my t's. So t of negative 2 is the purple dot, t is negative 1 at the black dot, t is 0 at no dots, t is 1 and t is 2. So, kind of weird when you graph because you have to graph 3-dimensionally on 2 dimensions. So, alright, then we're going to do the same thing in the next one. It's probably easiest if we change these to be their degree measures, just because it's a little easier to see where we are. Alright, so either way, at x of 0, so plugging in a 0 for cosine of t, cosine of 0 is 1, cosine of 90 degrees is 0, cosine of pi and we end up kind of with this pattern here of 1s and 0s. And then the next one, if we do sine of 0, we're going to get 0. If we do sine of 90 degrees, or pi over 2, we get 1. Sine of pi ends up being weird value. So, sorry, sine of 90 is 1, sine of 180 should be back to 0. sine of 270 is -1, and sine of 360 goes back to 0. Sorry, this one should be a -1. Okay. Alrighty, so either way I was having some fun calculator issues. Okay, so we're going to go ahead and graph our first dot at time 0, so that's going to be over at 1, up nothing, so that's time 0. Then we've got time pi over 2, so that's over nothing up 1, so that's here. The next one is going to be at -1, 0. After that we go to over nothing down 1, and then back to the beginning again. So what that means is that we actually end up kind of in this circle. So again, going back to the beginning, you do want to indicate that this was time 0. This was time 90 degrees, or pi over 2. And again, it doesn't necessarily in this case make sense to call it time because it's a degree, but it could be that x is time at this point and that the movement for your angle is the t. Alright, because it doesn't necessarily always mean time, it's just that we use a t. And then the last one was at 270. And then of course repeating again because we're in a circle. Alright, so the next ones, they want you to graph the parametric equation in the specified parameter interval. Oh, that's this one here. And use a standard viewing window. Apparently I decided not to provide you with a graph. Okay. So that means that we are going to go to our y equals, making sure we're in parametric mode. And so in y equals, it's 3 minus t squared. And then the other one is going to be 2t. And so what happens is you're going to do your window to be from 0 to 10. So your t minimum is 0, your t maximum is 10, and then of course you do want to have a t step that's pretty small, so like 0.1 or something like that. And then hopefully everything else is kind of just -10 to 10 just to get a grip on what's happening. So if you do that, it looks like at 1, 2, 3, you add 1, 2, 3.5. You have this image. Alright. Then they want you to do -10 to 0. So again, going back to your window, same equation, but now it's -10 to 0. And so now hopefully you see that it's at 1, 2, 3. And 1, 2, 3, 4. It's actually this way. And then they want you to do -2 to 4. Okay, so going back to the window button again, -2 is your t minimum, 4 is your t max, and I just used 0.1 as my step. And so if we take a look at that, we end up with a kind of combined set. And so our image ends up looking like a little bit past this, in here, and that way. Actually looks like it's probably at -1. And of course you can check that by doing trace, pressing the trace key, and then you can type in -1 as your x. Oh, but that's not what it's going to do. So type in 4 as your t. And it'll show you, oh, -2 as your t. It'll show you that it's at -1, -4, which is this point here. Alright, Then we're going to eliminate the parameter. Oh, sweet. Okay. So let's go ahead and do that. Alright, so here's our x, and it's easier for me to solve for x versus solving for y. So I'm going to solve for x as, solve the x equation for t. Just because I'm used to having a y equals equation. But you can, of course, do it however you want. And then we have negative 3t. So we're going to have negative a third x plus 2/3. And so that equation is t, and it's going to go into this equation. So we're going to take y equals 5 plus negative 1/3 x plus 2/3, which used to be t. And so our ultimate equation is going to be negative 1/3 x plus 5 2/3, 17/3. Gross. Okay. Then they want you to identify the graph of the parametric curve, so we're going to go with linear. Yeah. Okay, because it's got a power of 1. So the next one, let's see, I'm going to have my x that I'll solve. Only this time I'll have to subtract a 5. Ooh. Divide everything by negative 3 again. And get negative 1/3 x plus 5/3. Alright, and then my y equation is 2 plus t. So 2 plus the t equation, which was negative 1/3 x plus 5/3, which again used to be the t. And so I just need to add the 2 and the numbers. So my equation is negative 1/3 x plus 11/3 for adding our fractions there. And that one again is linear. It's got a power of 1. Alright. Let's see. The next one I'm going to solve for t. So when I do that in this first equation, x equals t squared, but I'm going to eliminate the t and by solving for x in terms of y. They do want us to go backwards. So normally I try to solve this first one as much as possible so that I get y equals, but this is the one they want you to do it the other way in order to make it work a little nicer. So instead we'll start with our y equation and solve for t, so I'll subtract a 1. And since that's what equals t, then I'll take the other equation, and instead of t squared, I'll do t, which is y minus 1, because that used to be t, and square it. And so then if we solve that, we get y minus 1, but it's expanded. So you can do your FOIL, or you can do the area model. So we've got y squared minus 2y plus 1. And so that is definitely in a quadratic format. And then this last one, hopefully you would notice already, since it's got sine and cosine, that it would be a circular equation. But let's see. So what I'm going to do here to eliminate the parameter is actually go to my notes, because it is not going to be helpful to undo cosine within here. So if we go to, sorry, not your notes, but your formula sheet, if you have x equal to r cosine plus x1, you can actually put it back into either this equation or this one. Of course, I like this one better because it's got y equals. But, of course, this one looks more like the circular equation, so it kind of just depends, mostly in this case, on what the answer key has, so you can compare your answer, but Alright, so in this case, in x, I'm looking for r cosine t plus x1. So my r in this one is 4, and then my x1 is apparently 0 because there's nothing there. And then for the other equation, again, my r is probably 4, and then my y1 is probably 0. So let's just double check that that's what we're looking at here, yeah. And so then if we convert it over into this equation, that means that we're going to have y equals plus or minus 4 squared. And then we're going to subtract x minus 0 squared, so subtract x squared, and then add 0, but that's not going to change it. So we can take that off, and then of course simplify just a little bit by making 4 squared into 16. But this is our circle equation. And again, you kind of know it's going to be because you have sines and cosines. Alright, then this last one always gets everybody, but here we go. We're going to find the values of the parameter that produces the graph in the indicated quadrant. So, basically we're trying to find out what t's make this piece, then what t's make this piece, because that would be in quadrant 1 versus quadrant 2. What t values will start in where it meets this quadrant and then go here for quadrant 4, and then the last quadrant here. So all we need to know is what t values make that possible. So our equation is right here, and it goes from -3 to 3, and so if they're plugged in. So most likely if I start with -3 and kind of cut it off, I'm either going to start here or here, because it doesn't usually start in the middle. So let's go ahead and put this into our calculator, into the y equals. So I'm going to have x equals 2 minus the absolute value that can be found under the math key and over to the column of NUM, which is number. And then there's this ABS and a parenthesis. So what it looks like on your calculator is 2 minus ABS and then a T. And again, the ABS is under math and the column for number. So ABS and then T. And then your y equals is going to be T minus 0.5. That's an 8. Okay, 0.5. So then we go to our window, and we're going to say -3 for our t to 0. Why not? Let's see what happens if we do that. Looks like we're going from -5 to 5, so I do want to change my x's just so that it's easier to navigate, just like the picture that is provided. So if we press graph, I have just plotted from from -3 to 0, and it's gone all the way from here to kind of halfway to here. So that means that I need to actually, in order to get quadrant 3, it's definitely going to start at -3, but it is definitely not going to be to 0. So I need to find out kind of what that ending value is. Actually, if you just graph the entire thing in your window from -3 to 3, as it says would work, you can just go to the trace key and scroll over to figure out what t values work. So to get to the end of that quadrant, it looks like it goes to -2. And then if we continue on, let's see, it's probably -2, so -1, nope, 0, nope, 1. Oh, so it's between 0 and 1, so maybe 0.5? Yep. So to get into this quadrant over here in quadrant 4, we need between -2 to 0.5. The next one for quadrant 1 goes to 2, and then the last one to 2 to 3. Alright, done.